Welcome viewers, in this video we'll see the solved problem based on the sinusoidal response of RC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Transients, sinusoidal response of RC circuit, solved problem 1. So this is a given circuit. R and C is connected in series. R value 10 ohm, C value 60 farad. This is the transient current. For the given network, find the transient current. The question is we need to find the transient current. The voltage is sinusoidal voltage, 20 sin 50t. So applied voltage. So in this time domain, the equation of the above circuit is given us by using the KVL, Kirchhoff's voltage law. Applied voltage equal to voltage drop across resistor and capacitor. That is the Kirchhoff's voltage law. Voltage rise equal to voltage drop otherwise. So 20 sin 50t equal to resistive drop plus capacitive drop. Resistive drop is R into I. R value is 10I. The capacitance drop is 1 divided by 60. The C value 1 by C integral I dt. So by using KVL we obtain the equation for the given circuit. Our aim is to find the I of t. So we need to take the Laplace transformation on both the sides in order to convert t domain into s domain. After simplification we need to take inverse Laplace so that we will get the transient current. Take Laplace transform on both the sides. So 10 is constant. Laplace transform of I is I of s. 1 divided by 60. Integral I dt. Laplace transform of integral I dt is I of s divided by s. Equal to this 20 is constant. Laplace transform of sin 50t is 50 divided by s square plus 50 square. That is nothing but omega divided by s square plus omega square. Omega value is here 50. Now we'll take the I of s common. So 10 plus 1 divided by 60s equal to 20 into 50 is 1000 divided by s square plus 50 square. Now we'll take this 60 LCM. So the 60 is multiplied here. 10 into 60s plus 1 divided by 60s equal to 1000 divided by s square plus 50 square. I will go for the further simplification. So this is nothing but I of s into 10 into 60 is 600. 600s plus 1 into 60s. That is equal to 1000 divided by s square plus 50 square. Now we'll bring this term in that side. So this 60s will go in the numerator, 600s plus 1 will go to the denominator. So 1000 divided by s square plus 50 square into 60s divided by 600s plus 1. Now we'll go for the simplification. This 60 and 600 goes 10 times, is 6 times. Right? So this again, this 600 and 1000 goes 6 times. This goes 10 times. 6 goes 10 times in 60. So 10 into 10, 100. 100 yes. Right? So finally we got. So first we will divide 1000 divided by 600. So 10 times this is 6 times. This 6 is divided by this 60. So 10 times. 10 into 10, 100 yes. Divided by s square plus 50 square into s plus 1 divided by 600 is 0.0016. Now we'll take this equation number 1. Now we need to go for the inverse Laplace, but we cannot take the inverse Laplace of this form. So we need to go partial fraction technique. After partial fraction we can take the inverse Laplace. Now we'll see how to take the partial fraction technique. So now by partial expression technique the above equation can be expressed as, we can split the term. That is the main aim of the partial expression. So that we can easily take the inverse Laplace. A divided by s plus 0.006. This is one term. 0.0016 plus bs plus c divided by s square plus 50 square. In partial expression technique 2 or 3 methods available. This is one of the method. Here s is available, so only one constant a. Here s square is available, so that bs plus c, 2 constants are available. So this is the equation 1 that is written now like this. So both are equal. So equation 1 This is based on the partial fraction. Now we'll take the LCM of these two terms. So this term is multiplied with A, this term is multiplied with BS plus C, because here only one term available, this term not available, so it is multiplied. Now these two terms available on both the side go, so got cancelled. So finally what we got, 100 is S equal to A S square plus 50 square plus BS plus C S plus 0.0016. Now we'll take this equation number 2. So next our aim is to find the value of this A, B and C. A, B and C, so that we can go for partial inverse Laplace. Now we'll substitute the value of S such a way that it should cancel any term, so that we can find the other term. For example, here 0.0016 available. If we substitute S equal to minus 0.0016, this term become 0. So that we can easily calculate the value of A. So that is our A. So choose the S value such that the term got cancelled. So substitute S equal to 0.0016. So 100 into S is minus 0.0016 equal to A into S square minus 0.0016 square plus 50 square plus B into S minus 0.001S plus C into S plus 0.0016. S is minus 0.0016, right, 0.00. So these two terms are got cancelled, it become 0. So this 100 into this value is minus 0.16 equal to A, the square of this value, and it is added. Finally we got this 0.016 is this much value. So A equal to minus 0.16 divided by 2500.0000256. So by simplifying, what we got, minus 0.0000639. Right? Now we calculated the value of the A. B and C can be calculated by equating the coefficient of the equation without substituting the value, by using coefficient. So this is the equation, simplified equation, right? A S square plus that equation 2 is multiplied inside. So multiply, after multiplication, after expanding the equation, we got this. Now S square, take S square outside. So here A is available, here B is available. So A plus B. Take S outside. Here S is available. So 0.0016 B. Here one S is available, C. This A 5 square, that is 2500 A. 0.0016 C. These two are constant. So this is coefficient of S square, coefficient of S, and constant. So this equation is nothing but from equation 2, after expanding we got this. That is simple. Either equation 2 is available, that is expanded. Now equating the coefficient of S square. Equation of coefficient of S square is A plus B. Here coefficient not available, 0. So A plus B equal to 0, so that B equal to minus A. Minus of minus, A value is minus, already minus is there. Minus 0.00639. So both the minus become plus. So B is 0.000639 plus. Right. Now we'll equate the coefficient of the S. S is 0.0016 B plus C. That is equal to here 100. Coefficient of S is 100. Right. So we'll go for further simplification. So C equal to 100. Bring this term that side. Minus, so it become minus 0.0016 into B. B value is this value. So after simplification we got 99.99. The C value is 99.99. Now we can substitute this value A, B, C in equation 1. Then we can go for inverse Laplace transform. So this is the equation after the partial fraction technique. A by this term and Bs plus C divided by this term. Now we got the value of A, B and C, so that we can substitute the value. A is minus 0.000639. B is plus 0.000639. C is 99.99. Right. So now we can split these two terms. Here only one term available, so it is splitted. Then only we can take the inverse Laplace. Right. So after splitting, what happened? So this term 1, term 2. Term 3 multiplied by 50 and divided by 50 in order to bring the standard form. So it is rewritten. All three terms are rearranged like that. So first we splitted, then we multiplied by 50 divided by 50. So this 0.000639 minus is constant. We'll write 1 divided by s plus 0.0016. This is one standard form. 1 divided by s plus a. So that we wrote like this. And this is constant. Then s divided by s square plus 50 square. This is one more standard form. S divided by s square plus omega square. Omega is here 50. Right. See here, now it is written 99.99 divided by 50 is written separately. 50 divided by s square plus 50 square is written separately, rearranged. Why it is written like that? Omega divided by s square plus omega square. That is another standard form. Right. Now this is constant written as it is. So 1 divided by s plus this value is nothing but e power minus at. A is 0.0016. Right. 1 divided by s plus a. Inverse Laplace is e power minus at. This constant is written like that. So s divided by s square plus 50 square is constant 50t, cos 50t. Right, 50 is omega. Similarly, 50 divided by s square plus 50 square is sin 50t. Right, these two are standard form. S square plus s divided by s square plus omega square is nothing but cos omega t. Omega is 50. Omega divided by s square plus omega square is sin omega t. Omega is 50. So this is the final transient expression for final transient current. Right. So this is nothing but I of t. Now it is converted into I of t. So in this video we discuss RC circuit excited by the sinusoidal waveform. Finally we got the transient current of the given circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.